Hello. How are you guys doing?
Good, how are you?
Good. I don't exactly remember where we left off yesterday. Does anybody remember? Did we look at number 20? I'll share my screen with you so you have some idea what I'm talking about. Let's see here. So, did we already do this problem? Do you remember? Yeah, we did that problem. Okay. All right. How about this problem? Yep, that one too. Okay. How about this one? Did we do this one? Okay, well, I think I'll go ahead and just, oh, we have some people. Hang on just a second. You think so? Okay. Well, I think I will go ahead and start the slideshow. So we may have already done this one, but we'll go through it again real quick. So it says the federal budget is derived from several sources. So we have the individual income tax, social insurance receipts, corporate taxes, excise taxes, and other. And we want to first think about what's an appropriate type of a graph. And so we've got percents, and when we have percents, that's often a good time to be thinking about maybe making a pie chart or a circle graph, especially because we want to compare each part to the whole thing. Okay, so the relative size of each revenue source. Okay, and they have been rounded, so 47.4% got rounded to 47%, but it's really easy to see that nearly half of the budget is coming from the individual income taxes. Any questions about anything so far? Okay, and then next, we've got the average cost of tuition and fees at a public four-year college in 2003 and a private in 2003, and then for 2004 and 2005, all the way down to 2010. And again, we want to think, what's a good graph to display the data? And for this one, we want to show the trends over time. And also we want to compare the two types of schools. So either a double bar graph or a double line graph would be good for that. Okay, and so we've got a line graph. We've got the dark purple, which is the private, and the light purple, which is the public. And then we have the question of which college, public or private, did the costs increase at a greater rate? And basically, we want to know about the slope, okay? And so we can tell that the slope for the private is a lot larger than the slope for the public, but we can actually go ahead and calculate those slopes. So for the public, we can take the value in 2010, which was 8,123, minus the value in 2003, which was 4,686. So that's the change in the cost. And we're dividing by the change in the time, which was 8 years. And we end up with $429.63 each year. And then if we do the same thing for the private schools, we subtract the change in the cost over the number of years. Hang on one second. here. That doesn't look quite right. Okay, so the number on top is the difference, and then we need to divide that by 8. So that's actually giving us about $1,324 per year. So it's still larger, but it's not quite as bad as it shows here. Okay, so I forgot to divide by the 8 for this one. On number 25, we get the percent of people in each category who participated in TV viewing. So that means people who are college graduates, 91% watched TV, almost 75% read the paper, and about 95% had internet access, right? And we've got the 4 different categories of how much education someone has, and then the percent in that category who did each of the 3 things. So we want to think, okay, what's an appropriate type of a graph? And for this one, we can make a multiple bar graph. So here's the multiple bar graph, and the dark purple is the percent who watched TV, the light purple is the percent who read the newspaper, and the white was the percent who had internet access. That makes sense? Number 26 says the table gives the number in thousands of cellular telephone subscribers. So in 2003, now remember this is a number in thousands, so it's not really 158,722, it's actually 158,722,000. Okay, but just to make us not have such large numbers, each one of these would be multiplied by 1,000. Okay, and then it says what's an appropriate type of graph. And for this one, we are looking at a trend over time. So a line graph would be good. We could also use a bar graph. Okay, so here's a line graph that shows us the trend over time. Okay, and so we have on the x-axis, we have the years. On the y-axis, we have the number of cell phone subscribers. And again, that's a number in thousands. Any questions on anything so far? The number 27, it says, given in the following table are revenues for public elementary and secondary schools from federal, state, and local sources. So we can see in the 1930s, most of the funding came from local sources. It was over 80%, and the federal sources were less than 1%. But by the year 2010, now less than 50% of the funding comes from local sources, and over 10% is coming from federal sources. We want to think, how could we display this data? Okay, and for this one, we could use a line graph because we're thinking about the trends over time, or we could use a multi-bar graph. And we've gone ahead and made the multi-bar graph. So the dark purple is the federal. I notice how in the 1930s, there's hardly even a bar there because it was less than 1%. And the light purple is state, and the white is local sources. Okay. What trends do we see? So if we think about the dark purple, that's the federal, it's increasing steadily until the 1980s. And then it kind of dips down a little bit, although it does increase again at the end here. And then the state, that's the light purple, okay, it's increasing, it's nearly doubled, and then it's kind of dipping down and it's increasing again, right? And then the local starts out at over 80%, and then it's decreasing. Eventually, it gets down below 50%. Number 18 says, a company compared the commuting distance and number of absences. Is this really number 18? Yep, this is 28, so there's a little typo. It's actually number 28. So we're comparing commuting distance and number of absences, and we're going to make a scatter plot. And a scatter plot is a lot like what you normally think of, where you would have 8 for X and 4 for Y, and you'd put a dot there. And then we're going to put on a regression line. So here's our scatter plot. So we had an 8. Well, we actually have 3 different people in the company who commute 8 miles. So that's why we have these 3 dots stacked on top of each other. Okay, so that's our scatter plot. Next, we're going to do a regression line. Okay, so we've got the regression line. It's a best fit line that tries to capture the trend of the data. So in order to do this, we're going to find 2 points on the line. So it looked like this point right here, X was 5, and I guessed that Y was about 3.25. Okay, it's a little hard to tell. It's definitely somewhere between 3 and 3.5. And then if X is 20, it looks like Y is 6. So first I find the slope of the line. So we can call this X1, Y1. And then the other point is X2, Y2. So I did Y2 minus Y1 over X2 minus X1, and that gave me about 0.183. And we're going to use the equation Y equals mx plus b. We know what m is. The slope is 0.183. We can plug that in. We need to figure out what b is. So I know that when x is 20, y is equal to 6. So I plug those values in for the x and the y. And then I'm going to figure out what b is. So first I did 20 times 0.183. And I find out that b is 2.33. So now I know what b is. I can plug that in. So my regression equation is y equals 0.183x plus 2.34. Any questions about anything so far? Okay. And part C says predict the number of absences per year for an employee with a commute of 15 miles. Here's our regression equation. X is how long their commute is, and Y is the number of absences per year. So we're going to plug in 15 for X. All right, so Y will be 0.183 times 15 plus 2.34. So we have Y equals 2.745 plus 2.34, and it comes out to be just over 5 absences per year. So my best guess is that that employee would probably be absent 5 times each year. Okay, number 29 says, a report from the Bureau of Labor Statistics lists the 2010 median weekly earnings for both men and women of full-time workers in selected occupational categories. All right, so we've got this median weekly salary for men and for women in each category. And what we want to do is predict the weekly salary for a woman if the median weekly salary for a man is $800. So we can make a scatter plot with the salaries for men on one axis and the salaries for women on the other axis. And then we'll make a best fit line and use that to find the answer. So here's my scatter plot. I just plotted the weekly salary for the men and the women. Okay, men on the x-axis, women on the y-axis. And then I put in a good line that seemed like it went through most of the data points as best as possible. And now what I want to do is come up with an equation for the line. So this point seems like kind of a random point. It's actually one of the data points. So when X was 543 and Y was 423, that was this data point right here. And it looks like the line goes through it. So I use that point. And then when X was 200 and Y was 200, it looks like the line is going through that point. So that was that point, that other point that I chose. And next I'm going to find the slope of the line using y2 minus y1 over x2 minus x1. Okay, and so I use this as my y2, 423, and y1 was 200. And then x2 was the 543, and x1 was 200. So I plugged them in, and I found out that my slope was approximately 0.65. And so I use my equation, y equals mx plus b. I plug in the 0.65 for the slope. And then I need to figure out what b is. And I know that when x is 200, y is 200. So I plugged those in for x and for y. And now I need to figure out what b is. And I get that b is about 70. Okay, and remember b, I know algebra class was a long time ago, but if you plug in 0 for x, you find out that y is equal to b. So that's the x-intercept. And it does look like the graph goes through the point 0, 70. I mean, it's hard to tell, but it looks reasonable. So here's our regression equation. Y equals 0.65x plus 70. Now, remember, we want to find or predict if a man is earning a median weekly salary of 800, what would the woman be earning? So here's our regression equation. We plug in 800 for X, and we predict that the woman's salary is about $590. Did anybody have any questions about anything? Okay, so I just wanted to point out, looking at the graph, we saw that if the man was earning about 600, the man was earning 800, the woman would be earning a salary close to 600. So that's supported by our graph. And then on the previous problem, so we wanted to predict the number of absences if their commute was 15 miles. So if we look at the graph, if they have a 15-mile commute, according to the graph, the number of absences is also about 5, which is what we found when we plugged 15 into our regression equation. So it's backed up by the graph. Okay, and so that's it for today. Tomorrow, we're going to look some more at probability. Remember, you do have problems on MyLab to do, and you have a quiz. You actually have 2 quizzes. I've gone ahead and posted a second quiz. So the first quiz was about 3-dimensional shapes, section 12.6. And then the second quiz is about the volumes of 3-dimensional shapes. So if anybody has questions, you can go ahead and ask. Otherwise, we are all done for today.
Do you know how many questions the quiz is?
I think there's 10 questions, if I remember correctly.
Okay.
Okay, anything else?
So, do- so for the homework that we turned in before, you
Yeah,
know, spring break, is
yeah,
there any, do you still have those?
I do. Would you like me
Okay,
to send it to you by email?
I would appreciate that, yes.
Okay, I can do that. Anybody else have anything?
Can you please, if it's not too much, send mine too?
Absolutely.
Thank you.
Well, thank you.
You're welcome. I hope everybody is staying safe and healthy and sane. I know it's kind of crazy being all cooped up. Are you guys,
Same.
yeah, are you guys working or just hanging out at home?
Well, colds laid me off for like a month, so can't really.
Yeah,
It's just stuck.
Yeah, and I'm stuck at home.
yep. I'm stuck at home.
How's your son?
He's doing good. He's resistant to the idea of homeschooling. He thinks it should just be home watching TV.
Yeah.
Yeah. All
Well,
right. Well, take care,
have a good
everybody.
day.
Bye.
Bye.